Hello students, I'm looking at this function, x e to the x. We're going to look at the first derivative and the second derivative, and this is a less complicated problem than number 3. So we're going to take the first derivative to find information about increasing, decreasing, and local max min. So with this, I'm going to take the first times the derivative of the second plus the second times the derivative of the first, and that is my first derivative right there. Then I'm going to factor out e to the x, set it equal to 0. If I put the x equal to 0, that's never true. If I have the x plus 1 equals 0, I get x equal negative 1. I put the negative 1 on my f prime number line. Make sure you label these, because one's going to be f prime, one's going to be f double prime. So we're just looking at the first derivative. And if I substituted in a negative 2 and got a negative, f prime of 0, and I got a plus. So on this number line, this is negative, positive, which means the function is decreasing, then increasing. And if you do that with a little, I always do just a little picture here, decreasing to increasing, that means that that is a local min. See, it's a low point. So our conclusion is f is decreasing on negative infinity to negative 1. Right? F is increasing on negative 1 to infinity, and f has a local min at negative 1. Now look at that, negative 0.368. I put that negative 1 way back into here to get that answer. Remember, this is always plugging it back into the original function because you're analyzing f. Now in the same video, I'm going to go ahead and look at the second derivative, which is going to give us information on concave up, concave down, inflection points. So I take the derivative of the derivative. So my derivative was back here. So I'm going to have to do product rule, and then the derivative of that is e to the x. So when I do product rule, I get x e to the x plus 2e to the, well, here's the first times the derivative of the second plus the second times the derivative of the first, and then you have that derivative of the e to the x. And these two added together give you 2e to the x. And I set that to 0. This gives me e to the x equals 0, which can never happen. And then this one, x plus 2, you get x equal negative 2. I draw my second derivative number line. And, you know, the domain of this one is all real numbers, so we're not going to have to do anything with our number line. I put the negative 2 here, and I'm going to test a value over here, and I did. I tested negative 3. And to the second derivative, notice I put f double prime on this number line. And that gave me a negative, and put in 0, and I got a positive. And this goes from concave down, so it's kind of going concave down and then concave up. And that is called an inflection point. So I wrote f is, should be concave down. Wasn't thinking when I wrote that. On negative infinity to negative 2, and should be concave up. On negative 2 to infinity, and has an inflection point at negative 2. Now I plug the negative 2 way back into the original function here, negative 2 e to the negative 2, and that is our inflection point. All right, I'll be back for number 5.